Okay, I hope I'm audible to all students who are attending this lecture of statistical methods for economics. We intend to look at the first topic within our lectures on statistical methods for economics. This is called descriptive statistics. So all students who are attending this lecture can write the heading descriptive statistics. This is the first module I intend to cover in my lectures on statistical methods for economics. The books I prefer to follow for my lectures in statistical methods for economics. This is Probability and Statistics for Engineers by J.L. Devor. Fundamentals of Statistics by S.C. Gupta. And Statistics for Business and Economics by Alan Dexter. You will find all these books already uploaded in my app for going through the lectures of this particular course. Okay, so these are the three key books I prefer to follow. Along with that, I have also uploaded some more content, some more books for practice, which I will be informing to all the concerned students. Okay, now, first of all, let's look at some important terminologies which we are going to face in the coming lectures. So students should be made aware about some important terminologies. Okay, so let's first of all understand what is meant by a population. Although the topic is descriptive statistics, but eventually we are also going to focus on inferential statistics. That's the next branch of statistics, okay, where we have something called the population and something called the sample. Okay, so before digging deeper, let's understand what is meant by a population. So students can write that population is a well-defined collection. Population is a well-defined collection of objects under investigation. When we talk about population, it is a well-defined collection of objects. It consists of all possible set of observations. It consists of all possible set of observations under consideration. That means, students, when we are dealing with the population, we are dealing with all possible set of observations that concerned population can have. For example, if I have to check how the undergraduate economics students are performing, I will have to look at all possible universities in that particular country. For example, if I have to see how the students studying undergraduate economics are performing, let's say in US, then my population is going to be set of all possible universities in US. Okay, if I have to check how the students are performing at postgraduate level in economics, how are their scores in the US economy or the UK economy, then my population is going to be set of all possible universities in that particular economy, either US or UK. So when we talk about population, population is set of all possible observations under study. You are not excluding any observation. You are taking into account all possible observations. Okay. Then, since usually the population is very large and it's difficult to track every observation within the population, we now look at something called a sample. So what is a sample? A sample is a randomly chosen subset of the population. A sample is a randomly chosen subset of the population. That means a sample is lying within the population and the number of items in the sample are either less than or equal to the number of items in the population. So if I draw, suppose this is my just a pictorial representation. If this is my population, a sample is a subset of it. Subset means it lies within the population. In the real life, when we collect data, it's very difficult to choose every item in the population, because usually when we talk about field of investigation, in most of the cases, it's very large. It's not possible for me to track every student doing undergraduate economics at US in every university. There are so many universities, and within every university, there are so many students doing undergraduate economics. So what I do, if I have to check how the students are performing at undergraduate level, I take a sample. So from one university, I'll pick up a random sample. From another university, I'll take another sample, and so on. The sample is going to give me an idea about the population. So whatever characteristics, as an investigator, whatever characteristics I'm going to observe in the sample, I can form some conclusions about the population. Okay, so I hope all students attending this lecture have understood the definition and the difference between population and sample. We are going to use this more often when I do inferential statistics. Okay, but these are some important terminologies which I'm introducing in my module on descriptive statistics. Okay, so let me erase all this and let me come to the third terminology. So students should be aware with what is meant by a variable, and particularly a random variable. So let's first of all look at what is a variable. Variable is any characteristic. Variable is any characteristic whose value may change. Whose value may change from one object to another in the population. From one object, or I can write sample, to another in the population. So when we talk about a variable in statistics, it simply means that characteristic which keeps on changing values. For example, let's say I take a sample and I calculate the arithmetic mean. Now, if I take another sample, I will get another arithmetic mean, and so on. So I can say that arithmetic mean in this case itself is a random variable, because as I keep on taking different samples, I get different means. So a variable in statistics is any characteristic whose value may keep on changing. It's not constant. As I keep on taking different samples within the population, that variable will keep on changing values. Okay, so students should be aware about what is a variable. Okay, then let's quickly dig deeper into the types of data sets. In statistics, we deal with a lot of data. We collect it, we organize it, we present it, we interpret it. Okay, we form conclusions about it. So now when we talk about data sets, what are the kind of data sets we have? So I can classify them on the basis of the following. So students can write the first type, univariate data set. Univariate data set. I can write that it consists of the observations on a single variable. That means when we are dealing with only one single variable, it's a univariate data set. For example, I have to check how the students at one particular university are performing in undergraduate economics. That's a univariate data set, because I will be looking at the GPA or the marks of students in undergraduate economics. There is only one variable. Another example which I can write is, for example, the sample of the lifetime. We measure lifetime in hours of a particular brand of batteries, okay, is given by the following data set. Given by, so our variable is lifetime in hours, and then we are given some data. 5.6, let's say the first battery operates for 5.6 hours, 5.1 hour. I've taken this example exactly from the book Devor. So I can randomly take some numbers. This is a univariate data set. Why is it univariate? Because we only have one variable. What is the variable, guys? The variable is lifetime of a particular brand of batteries. And if I ask you what's the sample size of this, how many observations do we have? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 batteries. The sample size is 8 batteries of one particular brand. And these 8 batteries are telling us what's the lifetime, how many hours they can operate. Okay, so univariate data set basically talks about one variable, observations regarding one variable. In our example, the variable is lifetime of the batteries. Okay, so I hope students have understood. Then let's look at the second type of data set called bivariate data set. Bivariate, as the name suggests, contains two variables under study. So students can write that the bivariate data set consists of observations made on each of the two variables. For example, I can say that data set consisting of let's say height and weight for each basketball player. For each basketball player in a team. Students can clearly see it's bivariate. Why? Because now we are looking at observations for how many variables? Two variables. For every basketball player, we are interested in looking at what is the height of that basketball player, what is the weight of that basketball player. So essentially, you can see that we have how many variables? We have two variables, height and weight. So it's a bivariate data set. Another type of data set, as we all know, is the multivariate data set. In real life, we mostly deal with multivariate data sets. Obviously, it deals with observations regarding more than two variables. So I can write it consists of observations made on more than one variable. So more than one variable is multivariate, where two variable is a special case called bivariate. So I can write that bivariate is a special case. Bivariate is a special case of multivariate, which deals with observations regarding two variables. That means, guys, when we talk about multivariate data set, multivariate automatically includes bivariate as well. That means if I sum up, when you are dealing with observations regarding one variable, that's univariate. When you are dealing with observations regarding two or more than two variables, that's multivariate. But exactly if you're dealing with only two variables, that's bivariate. So bivariate is one special case of multivariate data. Okay, so I hope that students have understood this. Now, moving forward, let's also look at the branches of statistics. So this is all very elementary, which I am doing. This lecture is the first lecture within our module on descriptive statistics. So basically, this lecture is like kind of an introduction to various terms which we are going to use quite frequently. So students can think of this as just an introductory lecture. You cannot judge the whole course just by this particular lecture, because it's just an introductory lecture where we are getting ourselves comfortable with certain terms which I am going to use eventually in the further modules. Okay, so branches of statistics. The first one which we have started is the descriptive statistics. Okay, descriptive statistics, as the name suggests, is you are showing the results through either pie charts or graphs or diagrams or tables, histograms, scatter plots. So when you are using descriptive statistics, what is your objective? Whatever data you have collected as an investigator, you are trying to summarize and give some important features regarding that data, either using tables or bar diagrams or pie charts, etc. So I can write that an investigator, remember, an investigator is the person who is collecting the data for investigation. So an investigator who has collected the data, an investigator who has collected the data may wish to summarize, and describe important features of the data. Okay, so I can say that this entails using the methods from descriptive statistics. The investigator can use descriptive statistics to summarize the data and state important features regarding that data. So some of these, I can write some of these methods. Some of these methods may be graphical in nature. Some of these methods may be graphical in nature, such as construction of histograms. We all have done histograms at high school level, economics and statistics, scatter plots, etc. And other descriptive methods would include involve calculation of summary measures, like mean, median, mode. These are all measures of location. We'll be doing them in quite depth in this course. Then we have standard deviation, variance. These are measures of variation, coefficient of variation. We have done all this at high school level. Students who don't have a stats or an economics background, don't worry. I'll be covering all these topics in this course as well. Coefficient of variation. Then what do we have? We have correlation, coefficient of correlation, covariance, etc. There are so many, I can't write all of them. We also have trimmed mean, which I will be covering up in this particular course. We have many other measures of calculations. So these are called summary measures because they are going to summarize the data. So basically in stats, when you collect data, you show it through pie charts, graphs, diagrams, tables, and the summary measures are giving you the characteristics. What is the arithmetic mean? What is the median of the whole data? What is the mode? Mode is the maximum number of times a given variable occurs. Median, as we all know, is that value such that it divides the whole data into two equal parts. 50% of the observations lie above the median, 50% lie below the median. The mean captures the average. Standard deviation and variance capture the dispersion, how dispersed or scattered the data is. Coefficient of variation captures the reliability. To what extent is the data reliable or consistent? Consistency is captured by coefficient of variation. Coefficient of correlation is going to capture the degree of linear relationship between any two variables. And so does covariance as well. That means these are all measures of descriptive statistics because they're all going to help the investigator to summarize the data. The investigator is going to show the data through histograms, scatter plots, and the investigator is going to summarize the data through calculating mean, median, mode, quartiles, percentiles. I haven't mentioned them, but we will be doing them as well. Quartiles, deciles, percentiles, standard deviation, coefficient of variation, etc. So this is all what descriptive statistics is going to deal with. And in my coming lectures, I'll be talking more about all this in depth. After that, in the further modules, the next branch of statistics is going to come, which is called inferential statistics. So inferential statistics practically is not this module. This module is all to do with descriptive. Inferential statistics is something which I will be covering up eventually towards the end of this course. And what will this branch deal with? So it's all about sampling. So I can write having obtained a sample from a population, having obtained a sample from a population, an investigator would frequently like to use sample information to draw some types of conclusion about the population. That means once you have obtained the sample, you have made the bar graphs, diagrams, etc. You've done all the pictorial representation, diagrammatic representation. Now the job is that you are going to use that sample to conclude information about the population, because guys, the population is very large. In order to form some conclusions about it, we are going to put the sample under investigation. Okay, so I can say that is the sample is a means to an end. The sample is a means to an end rather than the end itself. Just collecting the sample is not enough. If you're dealing with data, just collecting the sample is not enough. You have to also form conclusions about the population using that sample. For example, I'm going to use the sample mean to find conclusions about the population mean. I'm going to use sample median to form conclusions about the population median, and so on. Okay, so I can write just one more line to finally conclude inferential statistics. I can write the techniques for generalizing techniques from generalizing from a sample to a population are all covered within the branch of, they are all covered within the branch of inferential statistics. They are all covered within the branch of inferential statistics. So if I sum up the whole paragraph, inferential statistics is going to deal with collecting the sample from the population and using that sample to conclude about the population. Very simple. Okay, so hoping students have understood this. Then we can quickly write what is the relationship between probability and inferential statistics. Now, when we talk about inferential statistics, we also have something called probability. Okay, so students can now write the next heading, relationship between probability and inferential statistics. Remember, sampling is again connected with probability, concepts of probability. So I can write, students can start writing along with me, then we'll understand this. In a probability problem, the properties of the population, under study are assumed to be known, and the questions regarding a sample taken from the population are answered. So in probability, what happens? Okay, in probability, we assume that we know the population. When we talk about solving a probability problem, we assume that we know the population. We assume that the properties of the population are known. And we question about the sample. Okay. However, in inferential statistics, problem, the reverse happens, guys. I can write the characteristics of the sample. The characteristics of the sample are available to the investigator, and this information is used to draw conclusions about the population. So the purpose of making students write these paragraphs is that you should be crystal clear before pursuing further with the course. When we talk about probability and inferential statistics, when we solve simple probability problems, our assumption is we know the population and we are finding answers about the sample. However, in inferential statistics, we know the sample and we are using that sample to form conclusions about the population. So it's vice versa. In probability, I assume that I know the population, and then I work on finding answers for the sample. In inferential statistics, I assume that I know the sample and I use that to find conclusions about the population. So if I draw a figure, I can say that suppose this is population, this is sample. When I go from population to sample, this all is based on probability theory. The whole probability theory talks about moving from population towards a sample. For example, in a deck of 52 cards, which is the population, what's the probability of getting an ace? What's the probability of getting a king? What's the probability of getting a queen? So what are we doing? The population is a deck of 52 cards. The population in my example is a deck of 52 cards. And getting a king or a queen or a jack or an ace is a sample. So often we solve these kind of problems in probability, where we find out the probability of having a king in a well shuffled deck of 52 cards, probability of getting a queen, and so on. So when you are moving from population to sample, it's called probability theory. On the other hand, when you go from sample to population, when you go from sample towards population in this direction, this is called inferential statistics. Because you know the sample. You know the sample. For example, I know what's the sample mean. And I will be using it to find, I will be using it to estimate the population. The sample mean will be used to estimate the population mean. This is inferential statistics. So probability theory is all to do with moving from population to sample. Inferential statistics is all to do with moving from sample to concluding about the population. Okay, so I hope all students have understood this. So I can now write what is the purpose of sampling. Although we have done it orally, we have understood it orally, but let's quickly write a note. What is the purpose of sampling? There are two purposes. There are two purposes of sampling. The first one is estimation. Estimation, that is to make an estimate, of some population characteristic. We are concerned with making an estimate of the population characteristic. Okay, based on the sample information. Based on the sample information. So under estimation, we are trying to estimate the population characteristic based on the sample data. And another very important purpose, hypothesis testing. I will be covering both these in my modules further. Hypothesis testing is done to examine. A hypothesis is what? A hypothesis is nothing but an assertive statement. So hypothesis testing is done to examine some hypothesis. A hypothesis is also called assertion, what we assume to be true about the population. We are going to examine some hypothesis about the population based on the sample information. Okay, so both these topics will be covered in detail in the eventual modules. Whatever modules I'm going to do towards the end of this course, this is the first module we have started today, called descriptive statistics. Whatever modules I'm going to do eventually are also going to cover estimation, theory and hypothesis testing. Estimation, I repeat again, you are using the sample information as estimators of the population characteristic. For example, sample mean can be used to estimate the population mean and so on. Hypothesis testing is you are making a statement about the population and you are testing whether the statement you have made is correct or not based on the sample data you have. So we are going to study both of these in depth in our lectures on inferential statistics later. Okay, so hoping students have understood the purposes of sampling. Then you should also be clear about, often we are going to refer to large versus small sampling. So students can write the next heading, large versus small sampling. Now, different books take different types of large and small samples, but I'm following a very standard and a globally recognized book, Probability of Statistics and Engineers by J.L. DeVore. Okay, if you look at that book, you'll see that if the sample size, n is greater than 40, we are often going to use small n to denote the sample size. So small n always denotes the sample size in all my modules of this course. If the sample size is greater than 40, then the sample is called a large sample. Called a large sample. And if the sample size is less than 40, it's called a small sample. So DeVore takes 40 as the criteria. If you have some other book or if you are referring to some other book, you can go by the judgment and the results of that book. But in most of the cases, if the sample size exceeds 40, we consider it as a large sample. If it is less than 40, we take it as a small sample. Okay, so hoping students have understood this. And then the last thing I intend to cover in this particular lecture is the types of samples. And I'm only going to focus on the important ones, not all of them. Types of sampling. So broadly speaking, there are three major kinds of sampling which we can do. One is called simple random sampling. One is called as the simple random sampling. If you open up the books, there are many, but I'm just doing the important ones in the lecture. Simple random sampling is when each observation of the population, has an equal chance of being selected. Each observation of the population has an equal chance of being selected in the sample. Okay, and this can be conducted. This can be conducted with the help of the random number generator. These days we have Excel, where on Microsoft Excel you can have a random number generator, or the lottery method, where you can put all the candidates, the names of all candidates in a jar. You can mix them and you can randomly call out names. The lottery method is a very famous method where all candidates write their names on chits of paper. And suppose I have to call out prizes, then what I do is I simply close my eyes, I mix the chits of paper in a jar, and I randomly call out names for prizes. So basically, if I sum up, simple random sampling is that method of sampling where each item of the population has an equal chance of being selected. So this, I can say that this is one of the most unbiased methods of sampling, because you're not biased. You are not biased to any observation of the population. That is why every observation has an equal chance of being selected. It's like saying that you are just literally closing your eyes and randomly picking up observations without looking at any of them in a biased way. So simple random sampling is the most unbiased method of choosing a sample, because each item in the population has an equal chance or an equal probability of being selected as a sample. Okay. Then we also have something called purposive sampling. Purposive sampling. I can say that purposive sampling is when sampling is done. So now there's a tinge of bias here. So sampling is done with some particular conclusion in mind. With some particular conclusion in mind, so that there is a bias. So that there is a bias towards some particular observation for selection. There is a bias towards some particular observation for selection. So when you are doing purposive sampling, you are deliberately or purposively choosing a particular set of observations, because you already have a conclusion in mind and you want to show that conclusion. To show that conclusion, you only target a particular set of observations. For example, if I have to show that how inflation is having an impact on middle class families, then my purpose is only to focus on middle class. In my sample, I'll not take the poor class or the rich class. If I want to see how inflation impacts the middle class families, how it affects the cost of living of the middle class families, then in my sample, I will purposively or I'll deliberately choose only the middle class families, families with incomes in the middle class. Okay, so this is purposive sampling, where you focus, where you are biased towards some particular observation for selection. The last kind of sampling is stratified random sampling. This is also an important method, and this is also widely used. Now, stratified random sampling is basically recommended when your population is quite heterogeneous. Heterogeneous means it has too many variations within it. You use simple random sampling when your population is homogeneous. Homogeneous means all items in the population are very similar, they're alike. But if your population consists of diversity, if your population consists of observations which are quite different from each other, then you conduct stratified random sampling. So I can say it is a mixture. It's kind of a mixture of simple random sampling and purposive sampling. Somewhat a mixture of simple random sampling and purposive sampling. Why? Because you are dividing the population into some subgroups. So I can say that in this method, the heterogeneous population, I hope students know what is meant by heterogeneous. Heterogeneous means the population itself consists of observations which are very different from each other. So in this method, the heterogeneous population is purposively divided into subgroups. I can, to be more detailed, I can write into non-overlapping subgroups. Into non-overlapping subgroups called stratas. Stratas are nothing but subsets within the whole population. Okay, or I can say subgroups. Stratas are nothing but the subgroups within the whole population. And then simple random sampling is carried out. Simple random sampling is carried out within each strata. So for example, suppose I have to look at the pocket money. How much pocket money does parents pay to their children? So I have to see the pocket money paid by parents to children. Suppose this is my whole population. This is my whole population. And this population now consists of students who are in grade 12, students who are undergraduate students, students who are postgraduate students. There are students who are doctorate students. So what we are doing is we are dividing the whole population into subgroups. And these are non-overlapping. So these are, let's say, grade 12 students. These are undergraduate students, postgraduate students, PhD students. What else is left? Research students, let's say job students, students who are doing their jobs, job market. So what we have done is, these are all stratas. Okay. So what I've done is, we have divided the population into subgroups. Now within grade 12 students, I'm going to conduct simple random sampling in an unbiased way. Within undergraduate students, another simple random sampling procedure would be conducted, and so on. So why do we do this method? Because my population is heterogeneous. Obviously, grade 12 students are different from undergraduate, from postgraduate, from jobs, and from PhD students. These are all quite different from each other in terms of their experience, in terms of their prospects, career prospects. So the pocket money might differ from pool to pool, from subgroup to subgroup, depending upon the requirement. So what we can say is that simple random sampling is not a good method. The better method is stratified random sampling, because in this method, I can divide my population further into subgroups, and then within every subgroup, I can conduct simple random sampling. That is why in the beginning I said that stratified random sampling is a mixture of simple random sampling and purposive. Why? Because the population I have purposively divided into grade 12, undergraduate, postgraduate, job market, PhD students, and then once I've purposively divided my population into subgroups, now within every subgroup, I'm conducting simple random sampling. So stratified random sampling is like a mixture of simple random sampling and purposive sampling. Okay, so I intend to stop in this particular lecture. We have covered all the basic terminologies involved in descriptive statistics and inferential statistics. In my next lecture on descriptive statistics, I'm going to talk about histograms. Histograms as one particular tool of descriptive statistics. Okay, so we are going to deal with histograms, the type of histograms, etc. in the next lecture. I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or you can call up or mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.